Hey, Patrick Sullivan here, and I want to talk to you for a few minutes today about superpower understandings and what are those. So, again, when I think about superpower understandings, I think about if students have these understandings, they can be very fluent and dynamic in their understanding of operations and numbers. So let's start with an example, 58 plus 37. So typically a problem like that is written like this in a textbook or shown this way. And we typically do that. Now, what's hiding behind those numerals are sizes of units. And so a student who has dynamic understanding of numbers sees numbers as a tethering of quantities and sizes of units. And I don't think the real world does children any favors, especially when you think about going to the grocery store. What things are packaged in tins? Eggs, nope. Hamburger buns, hot dog buns, nope. Soda, 6, 12, 24, 48, nope. Maybe hot dogs if we're lucky, but they don't really, in the real world, they don't have experiences with things being bundled together in packages of 10. So I want to take three problems. I want to show you, first of all, that tethering of those numbers and quantities, of quantities and size of units. But then I want to talk about equal exchanges. And lastly, I want to talk about analogous problems. So I want to start out by thinking about the problem 58 plus 37. Okay, and again, when we solve that problem, these are the actions that we go through. You can kind of see that in what I'm showing here. And that 15 ones, it's no longer 15 ones. You are equally exchanging 10 ones for 1 10. And so that's the action. So now, I also now think about, and I'm going to shorthand this because I just want to make a point. No pun intended. 5.8 plus 3.7. So each of those numerals is also attached, is attached to a different unit. But I'm using the same numerals. So what's going on here? Well, in this particular case, we have 8 tenths and 7 tenths, which combined is 15 tenths. So again, doing an equal exchange, those 10 tenths become 1 1. And so now we have two problems that we've done the exact same actions on with those numerals, but with different sizes of units. And I would call those analogous problems. So let's just do one more. 58 hundredths plus 37 hundredths. Again, it's 15 what this time? It's 15 hundredths. We do an equal exchange, 10 hundredths for 1 tenth. Again, same actions, but on different sizes of units, and the quantities are still the same. So all three of those problems are analogous to each other because by my definition, they're the same actions on the same quantities involving different sizes of units. So in this short video, we've talked about numbers as a tethering of quantities and size of units. We've talked about equal exchanges, and we've talked about analogous problems, all three of which are what I would consider superpower understandings.